Okay, so once again, in this lesson 2, we're going to focus on a special kind of transformation that is called a translation along a vector. And so if we have these two images, and this is from your lesson 1, we have two images, and the one down here below is the original. This up here would be the image, because it's going to be a picture. So we're going to have some transformation that maps the original onto the image. So we're going to go point for point. So I'm going to put my transparency here and show you how we're going to think about these. So think about what is the type of transformation that would be the simplest to map in this. And if you remember, this one maps really easily with just a slide. You can slide it up and make it coincide. But we're going to be a little more specific about this transformation. And I want to, we're going to call this a slide. We're going to call a translation. And we're going to think of it as a translation along a vector. So if I think of this as maybe like point P, then this would be the image of P, or F of P. And what I'm going to do is draw what's called a vector. And a vector is just a line segment, but it has something extra to it. It has a direction. So this would be the vector that would define the translation that we're doing. So that would be one, but I could pick another point, another corresponding point. So if I picked this point here, maybe I could call that point Q, then the image of Q would be right up here. This would be F of Q right there. And I could show that by this vector. And you might notice something about these two vectors, because these two vectors are defining the same transformation. And one thing you might notice about these vectors is that they both have a specific length, and they both have a direction. So let me rearrange here a little bit. So a vector, and you might know another name for this geometric figure. We have called that array. Not quite have that on the video. We've called that array, but we're going to call it a vector when it comes to these transformations, because a vector has length. So that segment is a specific length that tells me how far the image is from the original, and it has a direction. Now, those of you who are studying physical science this year, you know that we've been talking about velocity being a vector. Velocity has a component of size, which is the speed, and then it also has direction. So it has those two things. And when we have a vector, let me draw it up here. If I have a vector that has a starting point and an ending point, and we put a little arrow there. So if I have, this is A and this is B, I'm going to call this vector AB and put a little arrow over it like that. So it shows that I'm starting at A is my starting point, B is my ending point. If I had, say, the opposite vector, if I had A here and B here, but I put the arrow that way, this would be vector BA. Okay, so we always name the vector with the starting point first and the ending point last. So that's a little bit about vectors, and what we're going to be doing is using these vectors to define a translation.